All right, so we are going to start by importing our geometry here. Now, as you can see, we have files for each of the shapes that were used in for simulation in this lab. This was for convenience, so we didn't have to continue to modify the same file to add objects within it. They were all pre-made in SolidWorks, and all of the dimensioning and pictures of those files are included in section 1 of the report, of the appendix. Sorry. Now we are going to move on to meshing. Now we need to start by making named sections. We have to define what each of these edges are. So first we are looking at the walls right here. Then we are going to move on to the outlet. And then after that is the inlet. We have one more thing. We go zoom into this circle right here. This is the cylinder that we're working on. And we're also going to define this as the object. All right. Next, we're going to go to the meshing and we're going to define the element size. This will just be a relatively small element size, something that gives us a lot of definition. So we have a very defined region both around the object and throughout the wind tunnel, so we can make accurate analysis of any individual point that we may choose, particularly around the object, though. Just taking a second here. All right, here we go. This is the mesh. As we can see, it's a nice smaller area right around the edge of the object and just a very defined overall meshing. Now we can close out. You can ignore that. We'll just close out and we can move on to the next thing. The meshing will transfer over just fine. So now we're moving on to the setup process. We always just put 8 in double precision, just as a force of habit. And once this loads, we can get started. All right, here we go. You can see everything's loaded in. Due to the way that we named each section, the outlet and inlet are already set up that way with the arrows. We're going to change the velocity magnitude to what we have previously calculated, going into the wind tunnel. This is going to be the inviscid flow simulation over the cylinder, so change that setting from viscous to inviscid. All right, now we are going to initialize the simulation. It's going to get started. It should converge pretty quickly. All right. Now we can view just the iterations as they go. Um, is showing our x and y velocities after each iteration. All right, it is finally finished. All right, now we are going to make a plot. We're going to look at the velocity magnitude. This is just going to show us the overall velocity throughout the flow. You see that the graph peaks out here at around twice the velocity within the wind tunnel, which is to be expected. It's what we were looking for. And then we are going to graph the static pressure. We're going to observe this. This is important for our coefficient of pressure calculations. Good observations. This is also what we expected to see. And yeah, that's pretty much it. Thank you.